And welcome to space. Welcome to the Daily Space Weather. This is our third segment of the day here. This is our bonus feature segment showing you things like the ionosphere and GPS errors, which is what we're looking at now. The total electron content forecast shows you how many electrons your GPS satellite is likely to be communicating to your handset through. And it can cause GPS errors of thousands of miles. They're usually concentrated around the equator. We see some anomalies here over North America, over Antarctica. So some anomalies there in the total electron content forecast. What you were looking at there is the area between your GPS satellite and your handset. So the plasmasphere and the inner Van Allen belt are where those electrons are located. No charging hazards at the moment, so no likely communications errors or satellite breakdowns. Here's the 1-year chart of the relativistic electrons as measured by the GOES 16 and 17. Here's the past 3 days. We are expecting an uptick here following the subsiding of the most current coronal hole high-speed stream. And there's the NOAA forecast model for that. Next, we're going to show you the ionosphere, the ionogram and anomalygram for the F layer, located around 300 kilometers of altitude. Here's your ionogram for the past day. This data courtesy of Australian Government Bureau of Meteorology. And here's the latest image. We'll also show the anomalygram. This is showing you anomaly in megahertz from the 30-day median. And we see lots of high-frequency anomalies here south of the equator at the moment in the past 24 hours, and continued swings in anomalies over Central Africa. Anyway, let's bring up the latest image here for the anomalygram and move on. So there's the ionogram at 12:30 Universal Time, and there is the anomalygram. Again, low-frequency anomalies largely below the equator there, south of the equator. I would welcome everybody to the Neo Renaissance and invite you to check out our homepage. We've recently made some changes at smashamash.com, announcing what our next chapter is. If you want to read about it, well, go ahead to smashamash.com. Links below the video. You can also find links to the Smash Team, thanks to Smash Team, especially Gold, Silver, and Gold Annual paid-up subscribers. There's the only teaser you get, as it's similar to Patreon for paid subscription services. Our next bonus feature is the ground-based solar observatory at Cerro Tololo, Chile. Yes, Sunspot 2936 is likely to produce major flares, increasing the flare probability to over 50%. Don't be surprised to see major flares, folks, from Sunspot 2936. As we see things like Terminator events becoming more and more likely to happen. Cycle 25, it's turning out to be quite interesting indeed. Next thing we've got is the solar intensitygram and the colorized magnetogram. Check out the fields on Sunspot 2936. There are the umbrae. That's also beta class. That's also beta class. That's alpha class, but this is beta class. And our regular viewers would be aware that beta class sunspots much more likely to produce major flares than more simple alpha class sunspots. It's all got to do with their magnetic field complexity. Sunspot 2936 is the star of the star at the moment. You can see quite a bit of its, I'll just say it's beta gamma class at the moment. Don't be surprised to see an M-class solar flare. From that, here's the most current imagery from the NASA GOES 16 SUVI. It's 304 angstroms, ionized helium. And we'll close out with some additional imagery here of the closest star. Here's Sunspot 2936 in its full, in-your-face glory as it moves closer and closer to Earth. And let's close out our bonus feature segment here with a full disk view. This is composite imagery here. 131 and 94 angstroms are the best wavelengths from the SDO through which to view solar flares because of their temporal resolution. Congratulations on realizing the channel exists. Thanks for tuning in, folks, and may that solar wind be at your back.